Hello students, I am Dilip Udani, Assistant Professor at LC Institute of Engineering and Technology. Today in Fourier series, I will teach you how to find out half-range Fourier series. So in half-range Fourier series, we will see how to find out half-range sine series and half-range cosine series. Half-range sine series is a series containing sine terms only, whereas half-range cosine series is a series containing cosine terms only. So let's start. Half-range cosine series of a function f of x in the interval 0 to L is given by f of x equals to a0 upon 2 plus sigma n is from 1 to infinite an cos n pi x by L, where a0 equals to 2 upon L integration from 0 to L f of x dx, and an equals to 2 by L integration from 0 to L f of x cos n pi x by L dx. Half-range sine series of a function f of x in the interval 0 to L is given by f of x equals to sigma n is from 1 to infinite dn sine n pi x by L, where dn equals to 2 upon L integration from 0 to L f of x sine n pi x by L dx. So here you can see from half-range cosine series, it is a series containing cosine terms only, and in case of half-range sine series, it is a series containing sine terms only. Now we will see one example related to this topic, that is, express f of x equals to x as a half-range sine series in 0 less than x less than 2 and half-range cosine series in 0 less than x less than 2. Comparing the interval 0 to 2 with 0 to L, we will get L equals to 2. Now first of all, we will see the half-range sine series of function of x, and that is given by f of x equals to sigma n is from 1 to infinite dn sine n pi x by L. Now we will replace L by 2, so we have sigma n is from 1 to infinite dn sine n pi x by 2. So here, first of all, we will find out bn, and the formula of bn is 2 by L integration from 0 to L f of x sine n pi x by L dx. Here we will replace L by 2, so this is 2 by 2 integration from 0 to 2, and f of x equals to x sine n pi x by 2 dx. So 2 by 2 it is 1, and we have to integrate x sine n pi x by 2. Now to integrate the product of these two functions, we will apply quadratic formula. So first of all, x will be as it is. Now derivative of x is 1. Then after, integration of sine n pi x by 2. And integration of sine x is minus cos x. So integration of sine n pi x by 2, it is minus cos n pi x by 2 divided by n pi by 2, because the multiplier of x is n pi by 2. Now again we will integrate this function with respect to x. Minus sign will be as it is. Integration of cos n pi x by 2, that is sine n pi x by 2 divided by n pi by 2. And again we have n pi by 2 over here, so it will become n square pi square by 4. And we have to give alternate sign, plus then after minus. And the limit is from 0 to 2. So first of all, we will put upper limit x equals to 2. So it will become cos 2n pi by 2. So 2 will cancel out. So it will become cos n pi. And the value of cos n pi is minus 1 is to n. And here you have to replace x by 2. And this minus sign will be as it is. And this term will be 2 by n pi. So 2 into 2 by n pi, so it will become 4 by n pi and minus sign outside, and the value of cos n pi is minus 1 is to n. Then after, if you replace x by 2 over here, so 2 will cancel out, and sin n pi, the value of sin n pi is 0, so this term will be eliminated. Then after, for lower limit, if you put x equals to 0 over here, so first term will be eliminated, and then after, if you replace x by 0 in this term, so it will become sin 0, and the value of sin 0 is 0. So this term will also be eliminated. So we have one term only, that is for x equals to 2. So Bn equals to minus 4 upon n pi cos n pi, and you have to write down this reason because sin n pi equals to sin 0 equals to 0. Now value of cos n pi is minus 1 is to n, so we have Bn equals to minus 4 by n pi into minus 1 is to n. Hence f of x equals to sigma n is from 1 to infinite Bn sin n pi x by l. So replacing Bn by minus 4 by n pi into minus 1 is to n. Minus 4 by pi is a constant value, so keeping this value outside the sigma function, so we have minus 4 by pi, sigma n is from 1 to infinite, minus 1 is to n over n, sin n pi x by 2, because the value of n is 2. So this is the required half range sine series of f of x equals to x in the interval 0 to 2. Now comparing 0 to 2 with 0 to l, we will get l equals to 2. Now we are going to find out the half range cosine series of f of x equals to x in the interval 0 to 2. The half range cosine series of function of x is given by f of x equals to a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by l. So in this expression, replacing l by 2, so we have a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by 2. Now first of all, we will find out a0, and the formula of a0 is 2 upon l integration from 0 to l f of x dx. So replacing l by 2, so it is 2 by 2 integration from 0 to 2, and f of x equals to x, dx will be as it is. 2 by 2 is 1, so no need to write down 1. Now integration of x raised to 1, according to the formula, integration of x raised to n dx, that is equals to x raised to n plus 1 upon n plus 1. So integration of x is x square by 2, and the limit is from 0 to 2. For the upper limit it is 2 square, that is 4 by 2, and the result is 2, and the for lower limit 0, it will become 0 square by 2, and that is 0. So the value of a0 is 4 by 2, and that is equals to 2. Now we will find out an, and the formula of an is 2 upon l integration from 0 to l f of x cos n pi x by l dx. Replacing l by 2, so it is 2 by 2 integration from 0 to 2, f of x is x cos n pi x, replacing l by 2, so it is cos n pi x by 2 dx. Now to integrate this function, we will apply boundary formula, and 2 by 2 will become 1, so no need to write down 1. Now we will apply Bernoulli formula, x will be as it is, derivative of x is 1. Now integration of cos n pi x by 2. So integration of cos x, that is sin x, and integration of cos n pi x by 2, that is sin n pi x by 2, divided by n pi by 2, because the multiplier of x is n pi by 2. Now we will integrate this function, that is sin n pi x by 2, and integration of sin n pi x by 2, that is minus cos n pi x by 2 divided by n pi by 2, and already over here n pi by 2, so it will become n square pi square by 4, and then after you have to give alternate sign plus, and then after minus, and the limit is from 0 to 2. Now first of all we will put upper limit 2. For upper limit 2, it will become sine n pi into 2 by 2. So 2 and 2 will cancel out. So it is sine n pi. So value of sine n pi is 0. So the first term will be eliminated. Now for second term it is cos n pi 2 by 2. 2 will cancel out and the value of cos n pi is minus 1 is to n. And this is minus minus plus and it will become 4 over n square pi square. So for x equals to 2, we will be having this term, and then after replacing x by 0, so this term will be eliminated because here it is x, and if you will replace x by 0, so it will become 0. And for this term, it will become cos 0, and the value of cos 0 is 1. So we will be having two terms. So for upper limit, we have this term, and the simplification of this term is 4 upon n square pi square cos n pi. And then after for lower limit 0, the term is minus 4 upon n square pi square cos 0. And you have to write down this reason because sin n pi, sin 0 both are 0. Now we will simplify this result. Taking 4 upon n square pi square common, value of cos n pi is minus 1 is to n minus value of cos 0 is 1. And again you have to write down this reason, that is cos n pi equals to minus 1 is to n and cos 0 equals to 1. So this is an. Hence f of x equals to a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by 2. Now replacing a0, the value of a0 is 2, so 2 by 2 is 1 plus replacing an by this term. 4 upon pi square is a constant value, so keeping this function outside the sigma function. So 4 upon pi square, sigma n is from 1 to infinite and minus 1 is to n minus 1 divided by n square into cos n pi x by 2. So this is the required half range cosine series, and here from this series you can see that this is the series containing cosine terms only. So today we have discussed how to find out the half range sine series and the half range cosine series. Thank you for watching this video. I will see you in the next lecture.